Hey folks, Mr. Dell here. We are gonna today, this video, explore area and perimeter given a set of algebra tiles and find their expressions in terms of their variable expressions in terms of for area and perimeter. But as well then, once we have those, explore this idea of actually finding the area and perimeter given values for x and whether the expression works or not. So let's get right into it. This is CPM. This is course 2, section 5.2.3, number 5-51. So I'll read it and we'll go from there. On your paper, sketch the algebra tile shape shown at right. Write an expression for the area and the perimeter of the shape. Then calculate the area and the perimeter of the shape for each x value. So I'm going to go ahead and draw this so that way we can have a better visual of it, and I can mark it up and it's a little bit bigger. So I remember algebra tiles, you have these, since those are marked x, these are the x tiles, right? So the x in the middle means that it's has a length of x. So from here to here is x, and then it's got a width of 1. So according to our original shape, there's 3 of them next to each other. So I'm just going to draw 3 of them right next to each other, like that. So that being said, each one of these little lengths up top is 1. And then the whole thing down here, then you could actually look at it together, would be 3, right? So this length is x, this length is 3. And then on the side, looks like they've taken 3 of these, what we call unit tiles, and stuck them on the side. Unit tiles, remember, the unit tile is a 1 by 1. So it really has an area of 1, right? So each of these areas and within it are 1. So each of these lengths around are 1, 1, 1, 1, 1, all the way around. And then inside here, remember, these are x tiles. So the area of those are x tiles. Now, what's interesting is this piece. So we've got the perimeter all the way around up to here. So it's this little side has a unique aspect to it, right? So to find that, we need to think about, well, from here to here, right, all the way across, all the way from there to there is x. The length from there to there, right, is x. And the length from here to here is 2. So there's 1, 2. So what's left over is x minus 2. So that length there is x minus 2 is what that is. So that's important because we need that when we talk about the perimeter, the distance around. So let's go ahead and get our expressions. So our perimeter, is x plus, this is x plus 3 plus, and then x minus 2, this direction. So I went x plus 3 plus x minus 2 plus what we can do. We can go 1, 2, 3, 4, 5, 6, and then another 3 make 9. So plus 9. Right? So I distance around 1, 2, 3, 4, 5, 6, 7, 8, 9. All right. And then this is unsimplified, so I can go one more step and simplify it. I've got 2 x's, and then I have a 3 minus 2 is 1, plus 9 is 10. So my perimeter expression is x plus 10. For area, remember, area is the stuff inside, and in the tile name is its area, right? That's an x tile, an x tile, an x tile. So how many x tiles are there? There are 3 x's, and then these are all units, and then there's 3 units. So that's my area expression, 3x plus 3. All right, now let's get into utilizing our values to find each of these expressions. So we've got A. It wants me to consider x is equal to 9 centimeters for A. So I need to figure out what is the perimeter given x is 9. Well, I can use my perimeter expression here, 2x plus 10, and I can go ahead and plug in 9 in place of the x, right? So instead of 2x plus 10, now it's 2 times 9 plus 10. So that's 18 plus 10, which is 28. And then it said centimeters, so I'm going to include my unit. So I have my perimeter is 28 centimeters. My area, the area expression is 3 times x plus 3. So instead of the x, I'm going to put in the 9. 3 times 9 plus 3, which 3 times 9 is 27, and 27 plus 3 is 30. So I would use my units. My units is centimeters, but we're talking area, so it's centimeters squared. So there's my perimeter and area given x equals 9 centimeters. Now B. B is unique here. So let's look at B again. B says x equals 0.5 centimeters. So I want for B to consider x being 0.5 centimeters. It gives us a little hint though. It says, draw a diagram. Does your perimeter expression work? If we look at our current diagram, and x is only half a centimeter, there's a problem with our current diagram, right? Because right now with our diagram on this side, we're assuming x is what? Greater than 2, right? If this works, this diagram works only when x is greater than 2. That diagram does not work if x is less than or even equal to 2, right? So in this case, x is not greater than 2, so that diagram doesn't work. So I have to rethink the diagram. So I'm going to start, if I think about it, these units, they're not changing, right? They're one by one. They don't change. They're not a variable. They're constant. But being x is 0.5, that means it's going to be this unit, this x tile is going to only be half as tall as the unit tile. So what I have here is that length right there is 0.5, but each of these still are 1, right? The x is 0.5. That's 1, that's 1, 1. So all the way around it's 1, but right here, this little piece is also only 0.5, right? Because this is 0.5 here, so that's 0.5, that little piece there. So if I talk about my perimeter for this problem, I cannot use my my perimeter expression. That's not going to help me because that comes from this one. So I have to actually have to draw a diagram on this one. So what we have 0.5 plus 1, 2, 3. I'll just keep writing it. Plus this direction, another 0.5, right? Plus 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I can just finish it off there. So I can count all the way around. I've got 13 ones and 2 0.5s, right? That little piece, 0.5, that 0 piece here. So my perimeter for this one is going to be 14 centimeters. Okay. So in if I go back to this, my expression wouldn't have worked. I wouldn't have got 14, and it doesn't make sense because I have a smaller x than 2. All right. And then C, my area expression would still work. My area expression, these are still considered x, right? If you think about it, 1 times 0.5 is x. So my area, I can still use 3x plus 3. And so I can plug in 3 times 0.5 plus 3. So 3 times 0.5 is 1.5 plus 3 gives me 4.5. Oops, that's a decimal in there. 4.5 centimeters squared for area. All right. Got my perimeter, got my area for, oops, that wasn't C. I was still on B. Sorry. So it's still on B. So I was doing B, still doing B. I don't know why I put a C there. So I have my perimeter and my area for B. All right, let me finish off C. C wants to utilize, they say use X equals 15 centimeters. So this one, X is greater than 2, so I can use my original diagram and I can use my original expressions, the expressions I found for perimeter and area. So I'm going to say perimeter is equal to 2x plus 10. Therefore, there we go. Therefore, it's 2 times 15 plus 10. So it's 30 plus 10, which is 40. So perimeter is 40 centimeters for C. And then area, 3x plus 3, which is 3 times 15 plus 3, which is 45 plus 3, which is equal to 48. And again, centimeters squared because I'm dealing with area. Okay, there you go.